And we're live. Okay. Hello all. Hello world. This is day 218 of studying compilers every day until I land a compiler role. My hair is acting up, but that's fine. Last time we tried to do copy propagation and we were like, low-key, we don't need to do this because we kind of already do that in SSA construction. I kind of want to look into that a little bit more, but maybe that's like an off-stream thing. But yeah, so we tried doing that. We didn't really get anywhere with it because of that. So we decided that value numbering was probably the next best place to look. So yeah, that's what we're going to be working on this time. We're gonna continue implementing value numbering. We got the very bare bones of it started last time. So this time we're gonna take our little scaffolding and we're gonna actually try to implement it. So yeah, it's gonna be a good time. So we have like our pass here, and then this is like the body of it. So we're gonna implement like here. Let's figure out how it works. I'm gonna reference the big Muchnick book again, but I'm fairly sure. Oh my god, why? Okay, let's settings. I'm gonna change my default app for that real quick. Let's see, default. This is just gonna be off screen because I don't want to mess it. I don't want to potentially leak a password or something. Let's see, PDF. That gets Firefox. Okay, perfect. So now, if we open up that, hooray! Okay. So yeah, we have the Muchnick book once again. Let's go to that. Let's go to... What is in redundancy elimination? Oh, I see. Yeah. Yeah, let's do value numbering. Maybe we should read through the basic block one. I think that's probably a good start, but I think after that we can... I don't think we need to implement this. I think we just implement the global one. Although it might be an interesting exercise to implement this, so who knows? We'll see. Yeah. Use hashing. Actually, something else I was thinking about, now that I think about it, if we wanted to split up inst combine into multiple passes in this one big file, so we have more granular control, that could be interesting. It would change the order we do things. So I'll bin that as something I want to do next time. Let's actually write this down. Let's see. We want split up inst combine into separate passes. Yeah, I think that might be interesting, and that might also help with a lot of sanity stuff. The other big thing that annoys me about this inst combine pass as well is that I can't make it just function level because, well, it just eats a big program, which is not good. Maybe I could just I don't know, if there's a way we could just construct it with yeah, maybe our pass manager should also yoink the operand manager thing, or whatever it's called in MIR. It's in value, no, or literal, whatever it's called. Literal map. Yeah, we should not have this here. This should be yoinked somewhere else. Yeah. Maybe we could keep a reference to it at all levels as well. That might be interesting. Or we could just make it a global, honestly. I think this is one of the things that's perfectly fine to have a global for. Or I guess is it a singleton? I don't know. Anyway. I guess we'll also add that to the list of stuff to do. Literal map is annoying. Okay. What's up, John? Or Jonathan? I don't know what you go by, but yeah. You are, in fact, first. It's good to see you. Okay. Anyways, infrastructure-wise, I want to split this up at some point, but that's a task for a different stream. What's up, Zaki? Okay. So we can worry about that later. Let's do, yeah, so we're focused on GVN right now, which is global value numbering, which is a variant of value numbering. So yeah. Let's just like read through this pile. This paragraph just says that like all of our other optimizations do similar things, but this is just like really, really powerful. Yeah, it can't quite delete everything, I guess. Or at least other optimizations can't quite delete things that this can. Okay, so originally it was derived on like just singular basic blocks. Eventually we figured out how to do it with more than just a basic block, and nowadays we do it pretty much globally, hence global value numbering, hence GVN. Yeah, so that requires everything to be an SSA, which is fine, because we already have SSA. We love SSA. Okay. It's applied to basic blocks. So this is the basic block local variant. So let's take a look at this. We use hashing to partition expressions that are computed into classes. When we encounter an expression, we compute its hash. If it's not already there, then we add it. But if it... Wait. If this is in non-assignment, we split it into two. I guess this makes sense. I feel like we kind of already do this. Oh wait, no, we don't. What's like an example of this? I guess I could like draw this out. I think that might help illustrate this. Maybe I could have my scratch pad on the right here. Yeah, hopefully this text isn't too small. I'll collapse the outline actually. That might help. Yippee. Okay, that actually seems perfectly sized. Okay, so if we have like, if, Jesus, that's large. Okay, so if we have if foo, and we have something in here. So this, what happens here is foo gets pulled out. So like, I equals foo, or let's use a different color. This turns into like I, or like temp, equals foo, and then foo gets replaced by temp. Just make sure you canonicalize before. Yeah, that's probably a good idea. Yeah, I think inst combine necessarily will take care of some of that. If there are things that can be like commuted, then I think that would solve that. I don't have like a canonicalized pass. I think inst combine will probably serve as that. I don't remember if LLVM has a canonicalized pass. I remember looking this up. I do not remember if it actually has something. Canonical form. Yeah, okay, so LLVM just uses inst combine for canonicalization. I guess I'll probably do that as well, for what it's worth. I think that will probably be fine. Yeah, and I'll need to like rewrite my tiles for that actually, but I guess it should be fine. Yeah, we'll see. Okay. Alright. So what happens is we basically just make a giant hash table of every computation in some capacity. If we're reusing a computation, then we just like use the previous variable declaration of it, pretty much. Yeah, so that's what that's saying. The hash function and expression matching function are they are defined to take commutativity into account, I guess. So that's like a little. I think that's a little theoretical thing that they just gloss over. Yeah, what's up? What's up, Lane? I am in fact reading again. This is quite ideal. Wait, so do they just gloss over this, or where's 12.12? It's 12.13, so 12.12 is here. Okay. The first and second instruction. identical modulo commutativity. What? Okay, well, sure. What's up, Izrit? Yeah, okay. So yeah, we're reading up on global value numbering because that stuff is cool and I want to implement it. Right now I'm trying to just understand the local variant, and then once we figure this out, we can read the section on the global version of it, and then we're going to implement the global version. I'm not sure how much time I'll have to do the implementation today, but hopefully there's like at least a sizable amount. Yeah. So, yeah, so we read through this. All of this says like we just make a hash table every time we compute something, and we like store it somewhere. We keep track of the right hand side and the left hand side. If the right hand side matches something that existed before, we just use like the left hand side, and then like if something is in this sort of structure, we just like we pull it out pretty much. Yeah. I think we account for that just by construction in our IR, right? It's like binary op necessarily is that, obviously. Call I think does. Let's actually just like look at a sample. I think the tests will be useful for this. Yeah. So like I think that's probably fine. Oop. Yeah, as long as we like pass it the same values, I think it should perform the same. I'm not sure if we should optimize out calls though, for side effect related reasons. It would pose a correctness problem, or correctness. Yeah. What else is there? Allocate, we definitely need to keep. Load, store are like different, I guess. Is there any that we need to split is the question. Phi is interesting to think about. Yeah, I guess the terminators maybe actually. Actually no, they just take values. So we do like enforce this by construction, which is nice. Yeah. Perfect. Yeah, so we just wait. Hash sequence is an array such that I is a sequence. Wait. What am I reading? Oh, what's up, Ziku? Okay. Data structure hash seq is an array such that each element is a sequence of indices. Oh, I see. That's a really funny way to explain it. It's just a hash map of arrays pretty much, as far as I'm understanding. What's up, Frothy? I haven't seen you in a second. I like to think I'm winning. Yeah. Okay, so we just have like we just have a hash thing, sure. So we can just like, I guess that's kind of difficult. How do we even like hash this properly? What's up, Trenton? Watching from the UW library. Ooh. Man. Sometimes I don't know, just a little aside. Sometimes I wonder what life would have been like if I didn't apply ED to where I did and I just sat on UW. But how'd you get into compilers? I took a class in my sophomore year. It was our I guess I can give the full story since it's been a while. So, in my fall quarter of my sophomore year, I took a PL class, and then one of my friends was like, yo, you want to take compilers? And I was like, I don't know, isn't that 20 hours a week? And then he was like, I'll take it if you take it. And I was like, bet. So then I took the class, and it sucked initially because I was terrible at writing code. And then about halfway through, I was like, this stuff is kind of cool. So then I like paid more attention, and then like it turned out to be quite cool. So then after the class, I reached out to the professor, and I started doing research. That's kind of carried me up to this point. But yeah, now I am, I guess, catching up on the gap in my compiler knowledge, pretty much. Watching this in confusion while downloading an Olama model, that's so real. Hash chaining. Oh, I guess that makes sense. Thank you. Yeah, of course. Okay, we're gonna need to... Huh. That's interesting. Is there like just a hash thing that exists somewhere? Actually, yeah. How would we figure this out? I guess everything that we can't value number, we can just like generate a hash from, or anything that we can't like equivalent replace, we can do that with. And then, I guess the base would be like either a memory root. We'll figure it out as we go, but I think we can just like take pointer hashes and then we can chain them together somehow. I need to figure out how that works, but we will worry about that once the time comes. Yeah, we'll just do a hash table for that, I guess. We'll do a hash table for the hash table, pretty much. That sounds wrong, but we'll figure it out. I'm sure the implementation is a lot different. Is it the same for global value numbering? We'll figure that out later. Yeah, I guess the implementation of this isn't particularly interesting. It seems very straightforward, at least. Like very one-to-one with just like the description. So I think we'll be fine on that. Okay, and the hash function does take commutativity into account. That's pretty cool. Okay. So match turns true if the expressions are identical, sure. So that's just a helper. And then this is like the erase, I guess. That makes sense. Okay. So oh man. What the fuck? Like, why are we writing pseudocode like this? One second, let me reply to someone. It is Pascal? Really? Wait, is this actually Pascal? Is there like an example program? It kind of, I guess it might be. Okay, well, I hate this, so sure it goes. So it goes. Okay. Let me lock in for a second, and then I'll catch up on chat. Okay, so we get that. Binary op, unary op. Sure. Otherwise, we just skip it, it appears. What the fuck? What are we doing? Do it. We got do it here. Just do it. Okay. Oh my god, there's more? Why is there so much? Okay, I'm just gonna read through this example. So 12.15a. Let's just snip this. Let's move it over here to the right side. What the hell? Paint on it, please. Please, I'm begging. We cannot be for real. Okay, there we go. So let's just follow this. Max hash equals 3. Okay. So we initialize to empty sequences. Set I equals 1. Block M? Oh, I see. So this, we have this. So this is a binary expression, is the right hand side. Okay, so we hash it to something. So this one exists. So we erase this. Wait, what? What the f? Oh, never mind. This is still in the same thing. Okay. This does not read very well. Why am I reading through this? Yeah, it should be like, it should theoretically be fine. I'm just like trying to follow it as an exercise. Okay. Okay, that makes sense, I guess. And then there's more pseudocode. Okay, I'm kind of lazy. I don't want to read this. I really don't want to read this. So match, then we replace. Okay, that makes sense. And then, wait, what? Remove all expressions that use its left-hand side variable. That sounds dangerous. Okay. Maybe I'm just like understanding what this does wrong, but surely it's like, it means like replace, at least. Okay, well let's just continue walking through this, I guess. So next is this one. We compute 2. Oh, okay, do it. Okay, I see. I understand do it now. It's literally do the instruction. Okay, so we compare, that returns true, has left. We replace the second instruction with that. Delete all instructions that use B as an operand? Oh, from all the hash chains, I see, okay. Yeah, that, sure. Yeah, that seems reasonable enough. Okay. And 3 is a unary expression on the right hand side. Oh, we're here, I see. Okay. Okay. Yeah, so this is talking about like inserting a temporary. I guess that's like fine. Okay, and then I don't want to walk through the rest of this. But yeah, that seems like simple enough. So surely this will all be fine. Okay. Yeah. So now it's time to do global value numbering. I'm scared. This is scary to read through. Okay. Earliest approach. Yeah, so we just care about this one. So, 1988. So, congruence of variables. So if the computations that define them have same operators / constant values, and their operands are congruent recursively. Yeah. So we need to make it more precise. SSA, we started reading through this last time. It didn't really make a lot of sense. Alright, so this just says we need to construct SSA, and we need to make a value graph. Oh man. Okay. Yeah, how do we do this? How do we want to do this? I guess we could just compute it as a local function to GVN, and then we can figure it out from there. Okay, so labeled directed graph whose nodes are labeled as operators, function symbols, or constants, and whose edges represent generating assignments, and point from an operator or function to its operands. Da-da-da. Okay, I just need to read this. I just reread this until this makes sense. I guess we could just look at this, I guess. Yeah, so mod is a function, as an example. Let's just take a snip of this. Yeah, this is gonna be fun to implement. Oh man. Yeah, okay. So then, yeah, so the nodes are, if we can go back to brush, there are operators or function symbols, or they're constants. And the edges are generating statements, so and these are numbered by operand order, for instance. So this comes from these two, because so this is a phi, so it comes from those two necessarily. But this assignment equals mod, passing in other stuff. This is 0. I'm not sure where that comes from. Let's take a look. Oh, we assign it 0. Okay, I see. Ezekiel, that seems like a pretty fire job. I can't lie. That sounds like, I don't know. That sounds like a. To me, that sounds like not a lot of work for a lot of payoff. At least that seems like a lot of fun. Okay. Yeah, and then we name these nodes, I guess. That makes sense. Those names are at the top of these. Okay. So given the code fragment here, that's represented by this. Only job that doesn't feel like work? Damn. Damn, you're lucky. You're hella lucky for that. Okay, yeah, this is SSA. Alright, so congruence is defined as the maximal relation on the value graph such that two nodes are Jesus Christ. That is a monster of a sentence. So, congruence is defined as the maximal relation on the value graph such that two nodes are congruent if they are the same, their labels are constants and constants are equal, or they have operators and their operands are congruent. Same operators and their operands are congruent. Okay. Great. Great. That's wonderful. God damn it. So where do these names come from, at least? Are these just like the SSA variable names? So that's I1, that's J1. Okay, I see. That makes sense. How would you suggest approaching books like Munchnix or Engineering Compiler? I guess part of the fun is like figuring out the solution, right? Like, I think the purpose is to, I guess, inform you of the theory, and then your job is to take that theory and translate it into a practical language, right? Like, it's less like research oriented and more like an engineering task, I think. I think that's how you should think about it, and that will kind of frame the way that you tackle the problem, at least. You think to use Vim to set up networking protocols? Hell yeah, that's actually like fire, man. Man, why am I trying to get a compiler role? I should just do that. ChatGPT explain this in Fortnite terms? Yeah, deadass actually. Okay. Congruence. Yeah, that's language. Is there like a simple definition or informal definition? Okay. Man, this is awful. Okay. So the inset of node. Ah. God damn it. Oh, yeah. Oh, yeah. Well, this is a lot less fun to read all of a sudden. Okay, this is very dense. Holy hell, this is dense. Okay, I'm struggling here. So, so, set of nodes in the value graph. Label maps nodes to node labels. Okay, sure. E-labels, set of edges from nodes to nodes. B is an array set by the algorithm to the resulting partition. Sure. Okay, so B is like the result, I think? No? P is... what the fuck is P? In, out, array. Okay, well, sure. Oh, man. Okay, lock in. Save all that. Can we just like read that explanation at all? Is that easier? So we have a work list and we have initialize. Yeah, this book is not doing so hot. Initial partitioning the nodes in the value graph. Work list with the initial work list. Sure. Arity. Sure. That makes sense. Follow edge. Okay. Let's see. Okay, sure. Computing arity is trivial. Nice. E log E. That's nice. Okay, so we have our work list. What does the default initialize to? Oh, okay, this makes sense. Yeah, I don't even know what the initial work list would be. I guess we could figure that out as we go. It just needs to be something. Okay, so we take it off. We get the node. Okay, yeah, I don't want to read this. This is going rough. I and J nodes are equivalent. God damn it. Dominator tree. Oh man. This is terrible. This is truly terrible. Yeah. I don't think this is gonna be helpful for me to implement it, I can't lie. So we might just have to do it by hand. We might have to do this a little bit. The scenic way. Okay. So let's figure this out. We have Dominator tree. I think we're gonna need that. We're definitely gonna need that actually. So let's start by registering that pass at least. Our reference for that is the same as we did in mem2reg. I don't think we need this in here. What else did we put in here that we don't need in there? I think that's fine actually. Do we need that? Yeah. We need map. We need ranges. Yeah. Okay. Well, sure. Yeah, the rest of that we do need. This is fine, though. We could get rid of something else as well. I forgot what it was. Inst combine ranges. Yeah, we don't need that here anymore. Okay. So let's... Yeah, so we need to overwrite register analyses. We need to yoink this. We put that there. Okay. So then, I think that's fine. That's not the right button. That's not the right button. Okay. So we can do that. We need to yoink Dominator tree. Okay, cool. So I think we could implement this like register analyses thing real quick. Right, we can just kind of steal that from here. Yeah, let's do that. And then GVN, register analyses. What are we missing? What? Is this insane? What? What is wrong with this? This is not... Oh, I'm in the wrong place. Whoops. Let's put that here. Much better. We don't need this. And then we don't need this. Yeah, we got that. What's up, Slow? Yeah, I am a slot piggy right now. Okay, what doing? What doing? What doing? I think that should be good for register. So now we just need to figure out what the hell we want to do with this. We need to store the graph somewhere. Oh man. I guess we shouldn't necessarily be making literals here. I think, yeah, there's not a world where we like make new values. I guess the whole point is that we don't need to make them. So I think we're good to split this off as a function specific thing. I might steal a new event config, go for it. That makes me very happy. If you use tmux, you should probably steal some of that. I'm actually going to push a change to it sometime soon, because real quick, if I make a new window and I delete this, I found out that you can, if I make like 5 new windows, I recently learned that you can use leader and then number key to switch between these. So 1, 5, 3, etc. So my mind has been blown at least. But it default numbers to like starting with 0, which obviously does not hotkey well, so I made some changes to like make it hotkey better for that at least. Lazy, I'm starting to feel bloated. Yeah, that's very reasonable. I've like tried to cut out as much slush as possible from mine, but it's all like personal preference at the end of the day. So your mileage may vary. Feel free to add stuff. Feel free to remove things. Yeah. We need to send a GIF real quick to someone. Okay. Okay. So if that, we need the function thing now, so let's, I think we can just yoink this pretty much. Yeah, we can do that. We need to, we might just need to yoink that header. Yeah, we can yoink that. I think we keep that, we get rid of this. There we go. Perfect. Okay. So now we get to have fun. Oh man. All we've done is infrastructure this far. How do we even do this? Like genuinely. Is there like a better resource? I guess this is probably fine. I don't think I need more. Surely this is sufficient. I guess we can just like go back to basics here. So congruence, something about that. Is it safe to say that like if 2 expressions are congruent, we can just like replace one? Defining assignments dominate P. Oh, I see. Okay. Yeah, that makes enough sense. Because we need to account for like fees and stuff. Grr. Is there like an easier thing to read? What does this say? Oh, that's pretty funny. Yeah, that makes sense. So I guess SSA is just like most of it then? Yeah, okay, so that's like SSA construction, that's fine. Oh, that's like fair enough. What this is? So I'm making a compiler from C to x86-64. I'm assuming you know what those words mean. If not, let me know. But yeah, one of the optimizations a compiler makes is global value numbering, which is like eliminating redundant computations. So I'm trying to learn how that works and trying to implement it myself. English, well, okay. Okay, so computers use like programming, or we write code in programming languages, and compilers read like ones and zeros, or computers read ones and zeros. So we need a way to translate from a high level like human readable programming language down to like, well, machine code. So the software that does that translation is called a compiler. And one of the things that the compiler does in that process is it optimizes the code to make it go faster. And one example of that is doing like redundant computation, or not doing like redundant computations. So like we don't have to, if we have like x plus 1 at like the top of a program and we have like x plus 1 a little bit further down, we want to ideally avoid doing that second one and just like reuse the value from the first one. So this optimization pretty much does that. It's very dense though. The textbook explained it in a way that did not make sense to me, so I'm trying to figure this out. Decrypting as well as making the code better than before. Yeah, in some sense, yeah, that's what a compiler does. But I'm focusing on the making the code better part, at least. Yeah. Okay. So right now I'm like looking at, well, Cornell's resources, I guess, because it popped up on Google. Okay, so this is like SSA construction. That's fine. Here we are. So there's this one. And that one. Or wait. What? Sorry, I'm responding to someone. Okay. Okay. So hash-based techniques, So they hash operations and find redundant values. In non-CS terms, what this means is like every instruction, we're just giving it like, we're giving it an ID pretty much. And we compute the ID in like a very specific way based on the operator and like the operands. So like if we have like 1 plus 1 or like 1 plus 2, the 1 and the 2 contribute to that in some way, and like the plus contributes to that that ID in some way. And then like if IDs match, then like we have the same thing pretty much. Allows for copy propagation extensions, sure. Yeah, then we have the dominator tree. Explain in medical terms, I'm not doing that one. I'm not doing that one, dog. Okay. Oh hey, nice. DVNT. Is that like authors or? Okay. Oh wait, you can do them at the same time? Wow. Okay. Yeah, we should not do that though. Yeah. Okay. We should do it like that. I'm not stuffing that into SSA construction, or I'm not putting it in MemThread. The aforementioned paper. This one? I hope it's that one. Oh, 2 approaches described in that. Okay, I see. That makes complete sense. Okay. Okay. Okay, so reverse post order. Okay. Remove and continue if meaningless or redundant. Me IRL. Set the value number. Actually, this is good pseudocode to read, I think. I hope I can scroll vertically on this somehow. Maybe I can, maybe I can't? No? Okay. Well, that's not very nice. This is a little small though, so we'll zoom in. So we just go through all the fees in a block? Or I guess this is per block, right? What is... Oh. Dominator value numbering technique. Okay, I see. So that's what that stands for. Wow. Okay. Then why are these showing up here? Oh, I guess we could just like combine them. That's pretty cool. Okay. Okay. So then, is this actually just like the entire algorithm? Like, is it that simple? Huh. So I guess we could just like make a work list, right? That'd probably be fine. Wow. Wait, that's crazy. Okay. I guess we do need like recursion still, so that's like kind of awkward. We would just have like a traversal order. Can we just like yoink the book actually? I think that might be a good idea. Let's just yoink the paper. Yeah, oh, that's not copy. Whoops. There we go. Here we are. Right? 1994? Oh, I see. Okay. Sorry. I think it's this. This seems like the right one. 1997. Wait. Hold up. Anyways. Can we read it? Okay. Let's see if I can get it through this. And if not, we will get it through other means. Through other means. Through, yeah, institutional login. Nope, okay. Alright, let's... Give me a second. Do-do-do. And... Okay, well that's not great. Is this up? This looks like it's up. Nice. We're dead ass. Alright, I'm... Sorry that this is like off screen. I kinda just gotta do it like this though. Here we are. Is this it? 1997. Okay, that is the correct one. Let's make that. Can we download this? Please? Come on now. Download. Oh my god, it's so slow. So how's everyone's day? How's everyone's day going? Hopefully this is not too uninteresting. Okay, we have obtained it through means. Yeah. I'm driving in circles in a tractor? Holy shit. Wait. Is it fucked to say that that's like low-key the life? Like, do you see like all the like really like cracked software engineers? They start at like an intern and then like they become a software engineer, they like climb the corporate ladder, and then eventually like it always turns into them going back to like just like whatever bullshit. Either it's like farming or it's like some random freelance shit. It's always back to Monk, I guess. And it always just takes me out. Reading and translating compiler book to Rust? Ooh. Hell yeah. We love Rust. We love Rust out here. Software to woodworking? Yeah, exactly. Like it's literally like that. It's so cool. Everyone finds the truth somehow, it appears. Sure. Okay. This actually seems like a better reference, to be honest. So you can use SSA. I guess what is this talking about up here? Actually, Firefox Dark PDF. Is this a thing? Oh, that is a thing. Nice. Let's just install it. What could go wrong? Oh, it's this extension. I see. Bruh. Oh, okay. Well, we have... Anyways. Let's re-download that. Actually, let's get rid of the PDF extension. That's really annoying. Okay, anyways, now that I've unleaked myself. What's a hash approach? What is the partitioning approach? Was the one that the other thing explained. So I guess it is like two distinct things. The partitioning approach seems difficult, or more annoying at least. It looks like what happens here is that the paper is taking the hash approach and just like extended it pretty much. Oh, it also makes the other one better as well. That's pretty cool. My garden's very extensive? Nice. Yeah, like every single, like, at least there's like this whole thing of like Asian families just like always having like some sort of a backyard garden. Like my home has, my parents have one, and it's like, it's so cool. Okay. Yeah, we might just do like the hash algorithms. Wow. Which one does LLVM use? Is this useful at all? I hope this is useful. Okay, this is all very basic stuff. That's not helpful. Okay. Oh, perfect. Okay, so it does just like... Oh, interesting. New GVN. Oh, that's a thing. The new LLVM's global numbering pass. Okay. This uses... Okay, so this is the partition algorithm. Essentially the same as standard RPO value numbering. One major difference. Sure. Every iteration process every reachable block and instruction in that block. Okay. I guess that makes sense. What is RPO again? Yeah, this is very interesting actually. I'm enjoying like reading through this. Yeah, I might have to save this paper real quick. Reverse post order. I see. Okay, that makes complete sense. Value numbering. Let's save this real quick. Sure. Yeah. Okay. That is a good call. Thank you. This is a nice paper. I like this paper. Long history. Yeah, sure. Okay. So they have to always produce equal values. There's two techniques. So this one hashes operator and the value number of its numbers of its operands. That makes sense. Sure. Constant expected time. Yeah, that makes sense. Second approach divides expressions into, oh god, the equivalence classes. Maybe I should do the partitioning thing. That's interesting. Oh, that, yeah. Okay. I might save like the substantive reading for next time. I feel like all I've done today is just like read, and it's like low-key like frying me. Yeah, we will read this next time. I think this should be like the big paper that I reference at least. Yeah, there's like this algorithm here. What does this come from? Is this hash? Yeah, this is under hash. And then if we were to look at, yeah. So partitioning, is there like pseudocode here? Didn't look like there was. That's not helpful. I guess we could just look at their original paper as well. Grow wheat for my own bread? That sounds fire, actually. That might be fun. Yeah, this congruence class stuff is like low-key tough. But yeah, we'll look at this next time, I think. Or maybe like the time after. We might split up inst combine first and like deal with this like literal map grossness. But yeah, I'm gonna call stream here today. Thank you all so much for showing up. If you haven't already, like the stream, and if you're new, make sure to sub to the channel. Also, while you're at it, check out the description. My Discord is there. It's the best place to get pinged when I go live because YouTube's notifs suck, and stay connected with everyone else in the community. My LinkedIn and my GitHub are there if you want to add me and keep up to date there. And my GitHub sponsors is there if you want to give me money. Yeah, I'm gonna eat dinner now. I have not eaten since like 1 p.m. and it's been like 7 hours. Take care, y'all. Take it easy. And I will see you all tomorrow.